Hello again, honors. I hope you are all having a wonderful day. We're here now for Unit 1, Lesson 6. We'll cut right to the chase, so I don't want to waste anybody's time. So, let me pause, turn off my volume, and switch screens. Okay, here we are. But I apparently... What does that mean, drag down? Okay. Alright. I don't know what happened there. Anyway, Unit 1, Lesson 6. Our learning target today, we're going to simplify expressions using the distributive property. I'm sure a lot of you are familiar with this, but it's going to be such an ongoing topic that we really want to make sure we've got it nailed down. So, make sure you have your notebook out. And, hold on, I'm going to pause because my cat's scratching my furniture. Hold on. Okay, I just stopped my cat from scratching on my table. I just took her to the vet the other day. He's 13 pounds. That's a huge cat. Alright. Here we go. Mathematical properties. These are important to know. They sound complicated. They're fairly simple. The commutative property. This one says we can use it for multiplication or addition. 2 times 3 is the same as 3 times 2. Same thing goes for addition. 2 plus 3 equals 3 plus 2. This is a property we can use for the distributive property, so it's important to know. The associative property. The associative property is essentially the same thing, but with more terms. So, it says 2 times 3 times 4 equals, let's say 3 times 4 times 2. You could also say 4 times 2 times 3, or 4 times 3 times 2. Any order works. In addition, same idea. 2 plus 3 plus 4 is the same as 3 plus 4 plus 2, or in any order you can think of. You can rearrange those 3, 4, 5, 6, 7 numbers, however many you have, in any order, and you're still going to get the same either sum or product. Now the distributive property says, this is the important one, I'm going to first put it in letters. This is one you'll definitely want to write down in your notes. If you have A times B plus C, that equals A times B plus A times C. To put it into a numeric example, we can have 2 times 3 plus 4 is equal to 2 times 3 plus 2 times 4. Now, I know in that example it seems unnecessary because you would add in the parentheses first. But we're going to get to examples where we use variables that we can't add because they're not like terms. So, let's get to it. Okay, try again. There we go, I think. I'm all over the place today. Okay, yes, let me move this in. So you can see it. Alright. Like terms are terms that have the exact same variable and the exact same exponent. Okay? So in that example you see at the top, negative x plus 3y squared, those are not like terms. The first term has a variable of x with an exponent of 1, and the second term has a variable of y with an exponent of 2. Right? Anything separated by an addition sign, those are terms. Okay? So like terms, like just numbers, the same variable with the same exponent, those you can add together. So if you look here at negative x squared, 5x, negative 4, we have a negative 3x, which you can see is the same color as the 5x because they are like terms. The 2 is the same color as the negative 4 because they are also like terms, also known right here as constant terms. Okay? So negative x squared does not have a friend, so it's negative x squared. 5x plus negative 3x becomes 2x. This is the associative property at work. It's telling us that even though those aren't next to each other, I can add them together. Negative 4 then plus negative 2 becomes negative 2. Okay, these properties work. 1/4 times 5 times 44. A lot of you could plug these right into your calculator, right? But what we want to do is simplify that by hand. Now 1/4 times 5 is going to give me fractions. But if I take 1/4 times 44, 44 is divisible by 4. So I'm going to use that property. 1/4 times 44 is 11. And I still have times 5. I end up with 55. 72p and 25p, those are like terms. Okay? They are like terms. 72 minus 25. This, I definitely recommend using your calculator. I don't want to see silly mistakes. We're now starting to focus on the algebra. I don't want the arithmetic to be a problem. Change to blue. 47p is my answer. Okay? Not p squared. It's 72p minus 25p. Think of it as a unit. 72 apples minus 25 apples leaves me with 47 apples. 7.3m plus 6.9n. We can't simplify this. These are not like terms. So this is simplified. Now the last example gives us an opportunity to use the distributive property. 14x plus 4 times 2 plus x. Now I know from order of operations we're supposed to simplify the parentheses first. But inside of parentheses we have a 2 and an x, which aren't like terms. So we can't add them. So we use the distributive property. This gives me 14x plus 4 times 2 is 8 plus 4 times x is 4x. Now I can combine my like terms of 14x and 4x, and I end up with 18x plus 8. Next page. For example, here we go with our terms. If you're feeling confident, pause it, try the problems, come back and see how you do. Negative 4x minus 5x, those are like terms, so my coefficients, I'm going to subtract. Negative 4 minus 5, I get negative 9x. Now over here I have a 3x term, a 4x squared term, and another 3x term. So I take 3x plus x, and I'm left with 4x minus 4x squared. Now we're going to do something called putting it in standard form. This is going to be very important as we get later, probably more towards chapter 5 and chapter 6. However, I want you to get in the habit. So I'm going to take the term with the highest exponent and list it first. So I'm going to rewrite this as negative 4x squared plus 4x. That negative stays with the x squared term. You can't just flip them. Here I can use the distributive property. Distribute, and I get 2d minus d squared. Again, I'm going to put it in standard form to get negative d squared plus 2d. Now this one looks pretty complicated. 2x minus 3 times negative 4x. 2x and negative 3 I can't subtract. So I'm going to distribute it to the other term. It happens to be on the right side of those parentheses, but that doesn't change anything. We know that because of the associative property. So I end up with negative 4x times 2x, which gives me negative 8x squared, because it was x times x. And negative 4x times negative 3 is positive 12x. This one's already in standard form, so we're done. Here I have negative 2 minus x plus 5. I can't add x plus 5 together. Okay? This is negative 2 minus the whole quantity. So I have to distribute that negative because it's negative 2 minus x minus 5. So negative 2 minus x minus 5. I have like terms of negative 2 and negative 5. So I end up with negative 7 minus x. To write it in standard form, I have negative x minus 7. This one looks more complicated. It's the same idea with more terms. Distribute your 3x. 3x times x squared is 3x cubed, because now there's 3 x's, plus 12x, plus 15x squared, plus 6x cubed. Now my like terms, I have two 3x terms, I have one x squared term, and one x term. 3x squared plus 6x squared is 9x, or cubed, sorry. 3x cubed plus 6x cubed is 9x cubed. Now to put it in standard form right away, I'm going to add the 15x squared, and lastly, plus 12x. This is what we call a polynomial, but we'll get to that later. Our learning target, we're going to simplify expressions using the distributive property. We threw in the commutative and the associative property because those are important. Okay? But really the focus is knowing how to use the distributive property. See how you did. I feel like I fly through these videos. I know that I don't want them too long. I know that our attention spans are short. It can be hard to sit through going on close to 12-minute math video. So again, write these things down, pause the videos, take notes, and please, please, please give me feedback. This is only Unit 1. I have plenty of time to change things for the upcoming units because my job is to cater to you guys. So, hope you learned a lot, and I will catch you on the flip side.